Okay, today we're doing Module 3 Quiz 1. For our first key concept, we're going to be looking at converting standard form to vertex form. Now, standard form is listed here. Y equals x squared plus 8x plus 12. This is the problem we're going to be working with. As you can see, it's in the correct form with the x squared here, the next x value here, and then just the 12, which is going to become a c. Or this is the y-intercept. Now, first we're going to group the x's together, and in this case we're using parentheses. So, x squared here, that's an x, so we're putting it inside the parentheses, and we're also putting the 8x within the parentheses. But because this 12 here does not have an x attached, it is going outside of the parentheses, and it's going to be right here. Now, we're going to factor out the leading coefficient, but because there is no leading coefficient here, we don't have to do this step. A leading coefficient would be like a 2x squared here. We would have to factor that out by putting it here, and so on. So, after that, because we don't have a leading coefficient, we're going to leave it how it is. But then, we're going to take the coefficient from the second x and divide it by 2 and then square our result. So this is the second x here. See, this is the first x, this is the second x. So we're taking this 8x and we're going to divide the coefficient, which is the 8. So we're going to divide 8 by 2 and we're going to get 4. And then we're taking our 4 and we're going to square it, just like it says here. We're going to square our 4 and this gives us 16. Now, we're going to take the product of the previous step, which was in brown, and we're going to plug it into the orange equation, which was up here, in exchange for the x value. So rather than this 8x, we're just going to have this 16. This was our orange equation, and we're just plugging that right back in. But get rid of the 8. It's just 16. So it's going to become y equals x squared plus 8x. But remember, we're getting rid of that, so it's going to become y equals x squared plus 16 plus 12. And then, in order to balance the equation, we're going to subtract the number that we added to x, which would be the 16, because look, we added the 16 to this x. We're going to subtract that from the outside of the parentheses. So, we're doing 12 minus 16, which is negative 4. And then we're just going to have our new equation, which is y equals x squared plus 16 minus 4. You're going to simplify this, and because it's a 16, we know that's a factor of 4, so we can do y equals x plus 4 squared minus 4. Now, the vertex form is y equals a, in parentheses, x minus h squared plus k. In this case, the x is just the x. We're not really concerned about that right now. And the h is equal to 4. As you can see, look. The h here is right here. And then, because it does have this negative sign, we're going to take our positive 4 and make it a negative 4. Then, for the k, just like here, it's listed here, and it's just negative 4. We're not changing that one. Okay, so the vertex is HK. So the vertex point is negative 4, negative 4. Okay, continuing on, we're going to do the second key concept in Module 3, which is the quadratic equation. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, this might look like a lot, but we're going to break it down. So, we're going to use the standard form in order to plug in a, b, and c. So, here is our problem in standard form. X squared, or should be, there we go. X squared plus 3x minus 10 equals 0. Now, a is the coefficient before x squared, but there isn't one here. So, we're going to use the implied 1. So, a equals 1. And then b is the coefficient before this x, which is 3, so b equals 3. And then c is the y-intercept, which in this case would be negative 10. So c equals negative 10. We now have our three values of a equals 1, b equals 3, and c equals negative 10. we're going to plug that into this equation up here. See how it fits? B equals 3, so we do negative 3 here, plus or minus, and so on. So here is what we plugged in. Negative 3 plus or minus this 3 squared minus 4 times 1 times 10. You can see where we got all of these numbers. Negative 10 here matches the C here. So C, we got negative 10, so we put that right there. 1, got 1, and that is where this goes, right here. The A and the 4AC. And the 3 squared comes from B, which is just B squared, and B equals 3. And then all over 2 times 1, which is A, so because A equals 1. So then we move on and we kind of simplify it some. We have negative 3 plus or minus 9, sorry, the square root of 9 minus negative 40. Now, we got this from doing some multiplication. As you can see here, 4 times 1 equals 4, times negative 10 equals negative 40, minus negative 40. Now we're going to actually make this an addition symbol, because a negative minus a negative is a positive. So we're going to get a result of negative 3 plus or minus the square root of 49 over 2. And the square root of 49 is 7. So negative 3 plus or minus the square root, sorry, this shouldn't be this here. It's just negative 3 plus or minus 7 over 2. So we're going to use these plus or minus signs and do two different x values. So negative 3 plus 7, negative 3 plus 7 over 2, and negative 3 minus 7 over 2. And negative 3 plus 7 is 4 over 2, which equals 4. And negative 3 minus 7 is negative 10 over 2, which is negative 5. So our x values for this equation are 2 and negative 5. And you're done. That's how you solve a quadratic equation. Okay, our final lesson that we're covering is the discriminative property. And you can ignore this. This was from the previous one. Okay, this property is used as a shortcut to find how many real or imaginary roots a quadratic function has. And the real or imaginary roots, that's how many x-intercepts it has. So if it has 2 x-intercepts, it has 2 real roots. If it has no x-intercepts, then it has 2 imaginary roots. Okay, so this is the rule. If D is bigger, which is this discriminative, the value of the discriminative. If the value of this discriminative is bigger than 0, then it has 2 real roots. But if it's equal to 0, it has 1 real root. That means it's just kind of like this. If you see one that just has 1 real root, it's the vertex. It's just that hitting point right there. If it has 2 real roots, you're going to see it kind of like this. Hits in both places. And if it has 0 real roots, or D is less than 0, then it has 2 imaginary roots, which is going to look kind of like that, or just anywhere that's not on the axis. Okay. So we can determine the value of the discriminative with the following equation. D equals B squared minus 4AC. Now this looks a lot like the quadratic formula, but this is just what we have within the radical. This, you can look back at the previous lesson and see that's what this is right here. It's just within the radical. We're just looking at that now instead. So you're going to solve it the same way as you did with the quadratic formula with your A, B, and C. So here's an example using the discriminative. And kind of ignore that answer already. Okay, y equals x squared minus 3x minus 4. So the coefficient here is the implied 1, so a equals 1. The coefficient here is negative 3, so b equals negative 3, and c equals negative 4. Now we're going to plug those into our d equals b squared minus 4ac, and we're going to get d equals negative 3 squared minus 4 times 1 times negative 4. And doing the multiplication here, we have 4 times 1. Okay, sorry. So doing multiplication here, we have 4 times 1 equals 4, and we're multiplying this 4 by a negative 4, which gives us negative 16. So we're going to plug in our 9 here from negative 3 squared minus negative 16, which is going to give us d equals 9 plus 16, because these are double negative forms of positive, and d equals 25. And because 25 is bigger than 0, we know there are two real roots, or two x-intercepts, looking more like this one.